All right, just trying to make a quick video here to get us some of our notes about equations of circles and ellipses, just like we did with parabolas. So circles, are all the points that are a fixed distance from like the center, and we get our equation of a circle. It looks like this: x minus h quantity squared plus y minus k quantity squared equals r squared. The key there is there's no coefficient for either of those x or y parentheses. So then if we want to think about where that comes from, if we have a circle, we put a point on it, x comma y, and we know its center is h comma k, we can find the distance using the distance formula, which, if you remember from your geometry days, square root of the 2x coordinates subtracted. So x minus h squared plus the distance of, or the 2y coordinates subtracted, y minus k squared, all square rooted. And we know the distance, that distance is just called the radius. And then if we square both sides, we get our r squared equals x minus h squared plus y minus k squared. So equation of the unit circle, well, we know the center is 0, 0, and it has a radius of 1. So that gives us x squared plus y squared equals 1. So if we move on to the next page here, just a couple quick practice questions. When you see your equation here, x plus 2 squared plus y minus 4 squared equals 9, I can read off that my radius is at, or my center, is at negative 2, 4, and my radius is at, or is 9. Well, r squared is 9, and so the radius is 3. So I put my point down, negative 2, 4, and then we can go to a radius of 3 in up, right, down, left, and then just make our circle. The other thing we can do is complete the square to write the equation. So what you'll notice here, for it to be a circle, we have the same coefficient for x and y squared, x squared and y squared. So if I group the x's and the y's together, 2x squared plus 8x plus 2y squared equals 24. We'll move the 24 to the other side. Factor out the 2 for the x's. And then I can do my complete the square step. Half of 4 is 2, squared is 4, so adding 4 there, but I really added 4 times the 2 in front, so that's 8. And so I'm adding 8 to this side, so then I get 2 times x plus 2 squared plus 2y squared equals 32. And since everything on the left side has the same coefficient of 2, we can divide everything by 2, and we get our final equation: x plus 2 squared plus y squared equals 16 for a center of negative 2, 0, and a radius of 4. 1, 2, 3, 4. Graph the top, bottom, left, and right. Oops, too close. And then just sketch our circle out. So that's circles. All right, so what is this? This is page 10. All right, so an ellipse, it's kind of like an imperfect circle, or a circle is like a perfect ellipse. Okay, the radius is different depending on where we're at, right? So we've got some different vocab terms here for an ellipse. So the center is h comma k. So let's label that. And I missed the first bullet point at the top. It's the set of all points in the plane the sum of whose distances from two fixed points is constant. Okay, we'll get to that in a second. So we have two axes for an ellipse. We have the major axis, which is the longer one. And it contains the center. It also contains these things called the foci. Not foci. Foci. That's how you say that. Plural of focus. So one of them is called a focus, just like a parabola had a focus. An ellipse has two focuses, which we call foci. And those are going to be C units from the center. Okay. So if we have the longer axis there, we would have, those are that's a focus, and that's a focus. And the distance there is C. We also, so it's in the major axis, it says the length of the major axis is always 2a units long, which means from the center to the edge of the ellipse is a units long. And we call those 2 points the major vertices. Because they're on which axis? Specifically, an axis that an ellipse has. Say, the major axis, right? So the endpoints of the major axis we call the major vertices. And then we have something called the minor axis. That's the shorter one. Right? And those endpoints we call the minor vertices. That one there. And that one there. Okay. And the distance from the center to the minor vertex is B units. Fix that one more time. There we go. B units. Okay. All right, there's a lot there. So we say the major axis is 2a units long, or the distance from the center to the vertex is a units. Okay. And so there's two types of ellipse. It could be a vertical major axis. So it's like a tall ellipse. And in that case, that means A is going up and down. So we say that A squared is under the y minus k. The B is the shorter one. That's horizontal in this kind of ellipse. So we say the B squared goes under the x plus x minus h. But if it's horizontal, like the one above, so it's longer on that direction, side to side. Now the A is side to side in the horizontal direction, so we put A squared under the x minus h, and B squared is under the y minus k. So I hope this gives you a little bit of a preview of how we're going to graph these, right? So the A squared number tells us how far to go in the x direction or the y direction, depending on which one's bigger. And the B squared number tells us how far to go in the other direction from our center.
So A is just the bigger one, and B is the smaller?
A is the bigger one, B is the smaller one. Okay? And that's our key, that is our key takeaway point. A squared is always the bigger denominator. Okay. And why that matters is because the formula for the foci is c squared equals a squared minus b squared. C squared equals a squared minus b squared. Okay. Kind of has a Pythagorean theorem feeling to it, but it's subtraction. Look back up at that picture from the top. Is C shorter or longer than A? Shorter, right? The distance from the center to the focus is smaller than the total distance from the center to the vertex, which is why we have to take that A value and subtract something to get C. So it's A squared minus B squared equals C squared. So that's how you can remember that this formula is subtraction, because we need to get something smaller than A squared. Okay. All right, flip to the next page here. Let's look at page 11. So graphing an ellipse from standard form. So we're going to find all this information, make a sketch. So when you look at this, x squared over 36 plus y squared over 16 equals 1. So first thing, it has to be equal to 1. And the center, what's our center here? H comma k, 0, 0. Nothing subtracted from x, nothing subtracted from y. So our center is at 0, 0. Let's start off easy. Okay, so then what I always like to do is I like to write kind of a summary here. Like a squared is the bigger one, the bigger number on the bottom. So a squared is 36, which means a equals 6. B squared is 16, which means b is 4. And then c squared is a squared minus b squared. 36 minus 16, so c squared equals 20. So c equals root 20 or 2 root 5. I like to put both, root 20 and 2 root 5.
Wait, so what is the C symbolize? Like A is the long length, what is C?
So C helps us find the foci. And as we haven't talked enough about the foci yet. Let's go through a couple of problems, and then you'll start to see where they come from, and then we'll talk about what they're actually for. Okay. So the major vertices. So because the 36 is under the x squared, I know the x direction is where I have to go 6 units. So I'm going to go from the center in the x direction, 6 to the right, and 6 to the left. In the y direction, I'm going to go, how many up and down? 4. So you've got your major vertices. And since it's 6 and negative 6, you can go ahead and put plus or minus 6 comma 0 if you'd like. Minor vertices, we could do 0 comma plus or minus 4. Okay, then the foci. And actually, so we've got our ellipse now, so you can kind of try to draw it. Kind of oval in shape. Okay, so the foci are on the major axis. On major axis. They always are. And they are C units from the center. So, from the center, I gotta go root 20 or 2 root 5 to each side. This is why I like root 20. 2 root 5, I have no idea what that decimal is. But root 20, I got a pretty good estimate. What perfect square is 20 bigger than? 16, so 4. And then what is it smaller than? 5. So it's somewhere between 4 and 5. That's all I care about. Somewhere between 4 and 5. So 1, 2, 3, 4, somewhere there. There's a focus. I'm going to put an F. 1, 2, 3, 4, and somewhere there. Okay. Between 4 and 5. But when I write out my actual coordinates, I do want to use, and I'm requiring that you use the simplified version. So don't put root 20 here, put 2 root 5. So it's in the x direction, plus or minus 2 root 5, comma 0. It says to label these things. So we've got the center. We've got, for what you could do is you could say the major vertices are just V. And the minor vertices are MV. There we go. Yeah.
So C is always going to be on the same axis as the major vertices?
Exactly, yep. C will always be on the longer axis. The foci will always be on the longer axis. So, at the risk of ruining this very nice picture, I want to talk about that first bullet point on the front, where it said, all the points that are a fixed sum from 2 fixed points. So what it's saying, let's start with this. If I drew a line, and I don't think you should draw these really, just kind of watch. If I draw a line from the focus to the minor vertex, and the other focus to the minor vertex, what do you notice about those 2 lines? They would be equal, right? Okay, they do make a triangle there. Whatever they add up to, whatever that total distance is, that will be the same no matter where I draw the point. That total sum will be the same every time. And that is what makes an ellipse an ellipse. All those points, the sum is the same every time. So that's the fancy definition of it.
So we have to demonstrate that?
You won't have to demonstrate that, no. But I think it's important to just kind of know where this is coming from and know that the foci aren't just these random points that we make you draw. They're actually what create the ellipse. Okay?
That doesn't work for any other point in the
In the middle?
Yeah, on the major vertices.
I don't understand your question.
That wouldn't work for any other. Let's say you put -2, -2, that wouldn't work for that.
So you're saying if I put
Let's say you,
a random point on the major axis, like that and that?
yeah.
Correct. It will not work for that. Meaning for this ellipse. But it would, if those are your foci, that creates a different ellipse.
Yeah.
Okay. So then, let's try another one here. Where are we at with time? 10 minutes. We're good. Okay. So, I know when we first gave you those equations at the front, you're like, oh, gonna memorize all those? Well, it looks like this. I don't think there's much to memorize. How do we know it's an ellipse? Both are squared. What's it equal to? 1. What symbol's in the middle? Plus. When we get to hyperbolas, it turns into a minus. Okay, we're not there yet. So center, but I'm not memorizing the h and k. You kind of know that, right? The x minus 3, that means my center's at 3, 2. 3, 2, center. Okay, great. I gotta do my a squared. What's a squared in this one? 49, so a equals 7. B squared is 4, so b equals 2. C squared is going to be 49 minus 4, or 45. So C equals root 45, which is 3 root 5. Okay. So which way am I going to go for my major vertices? Up and down, because it's under 49 is under y. So I'm going to go up 7 to 9. So there's 1. Now I can't do the plus or minus thing though. 9 comma 3. That doesn't seem right, because I'm writing that wrong. What is it? 3 comma 9. And then go down 7. 2, 4, 6, 7 to 3 comma negative 5. Minor vertices, I'm going to go left and right 2. 2 to the left, 2 to the right. So what's that? 1 comma 2, 5 comma 2. Sometimes when you draw it, it's not going to be perfect. It's not my best ellipse ever.
Wait, so
yeah.
So you get three red 5.
3 red 5.
Like on the graph. You got 3 there? Or?
Yeah, right. So 3 root 5, I don't know how to estimate, but root 45 I do. Root 45 is a little smaller than root 49. Root 49 is how much?
9.
7, right? So it's a little smaller than 7. But it's bigger than 6 because root 36 would be 6. So it's somewhere between 6 and 7. So I'm going to count up from the center. Not quite 7. So 1, 2, 3, 4, 5, 6, 7. So it's going to be pretty close to the vertex there. There's one focus. 1, 2, 3, 4, 5, 6, 7. There's the other focus.
Were you using calculator on this test?
No, not necessarily.
So just estimating.
Just estimating. Yep. But then when you write the actual coordinate, I know that that's 3, comma, and on this one, so because I'm adding a root, I can say like 2 plus or minus 3 root 5. I don't get an actual number, like a integer. Okay. There you go. Next page. Yeah, we'll do one of these to finish up. Page 12. So we got to actually go through the whole process, complete the square here. You can do that along with me. X squared minus 4x, leave some space, plus, I got to factor out 9, y squared, 6 plus 6y. 9 times 6 is 50. 6y equals negative 49. Let's see. We're going to add 4. Add 4. Add half of 6 is 3. 3 squared is 9, but I really added 81. Okay. So then I get x minus 2 squared plus 9y plus 3 squared equals negative 45 plus 81. I think that's going to be 36, right? Or okay. 85 take away 49 would be 36. So, how do I know this isn't a circle? The very first one we did where we completed the square, we had 2x minus 2 squared plus 2y, They both had the same coefficient, right? This one, they're different. That's how you know it's an ellipse. So instead of dividing everything by 9, that doesn't really help because I still have now I'd have over 9 for the first one. So I'm going to divide by 36. I'm going to get 1 on the right side. And usually when that happens, it reduces nicely. So we get x minus 2 squared over 36 plus y plus 3 squared over 4 equals 1. So we can mark our center, 2, negative 3. I know my a squared equals 36, so my a equals 6, and that's under x, so I'm going to go 6 units right. 1, 2, 3, 4, 5, 6. 6 left. 1, 2, 3, 4, 5, 6. So I can mark those points down, negative 4, negative 3. and 8, -3. Minor vertices, b squared equals 4, so b equals 2. So we go up 2 and down 2. So that's 2, -1 and 2, -5. And then my c squared is going to be 36 minus 4. C squared equals 32. C equals root 32 or 4 root 2. So a little less than 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I could label those foci. And then from the center, so the x coordinate changes, so it's 2 plus or minus 4 root 2, -3. Does that make sense of how I name that point? Or like write those 2 points?
Yes.
So then I should like finish this picture actually. Okay. Vertex, vertex. So the 2 is because to find those foci, I started at the center and went C to the right and C to the left, and the x coordinate of the center is 2. Okay. Vertex, vertex, center, minor vertex, there you go. Okay. Let's stop there.